There are many different ways we could go about writing this program, but the one thing that should be true of any approach is that you write a little bit and test it, rather than trying to write the entire program before testing it. Here's the first step I chose for writing the program. I wrote the signature for each of the functions, but I haven't written the code for any of the functions other than the main function. Note that when you write a function declaration, you must put at least one line of code for it to be syntactically correct. The Python pass statement is a statement that means do nothing. The same is true any place a line ends with a colon. You must put at least one statement after the line that ends with a colon, so you would need to do the same for loops and if statements if you aren't ready to write the code underneath them yet. This code will not currently run since the functions do not return values. In this next version, I wrote code for some of the functions so we can now run it. The getInputs function now returns 3 values as it should. It doesn't actually ask the user to input any values, but while working on the code, it's quicker to hard code in these values so we do not need to type in values every time we change the code and want to rerun it. One of the last things we'll do is change this function so it actually inputs values and returns those values. I've also hard-coded return values for the simEndgames function so we can call it from the main function and not have it crash. I picked the printSummary function as the first function to write completely, as it was fairly straightforward and will allow us to see if the other functions work correctly once we start writing them. This function takes the number of wins by each player as parameters and prints the wins and percentages for each player. I've used the original Python string formatting that is in the textbook, rather than the more recent one I showed you in one of the videos. We can now run it and see that it works as we expect, since we hard-coded that simEndgames returns 60 and 40. I like this approach of getting some code working and then adding features a little bit at a time. In this case, we will keep adding features that work to actually perform the simulation. As we add each part to the program, we can run the full program and see if that part now works. Other people prefer to write each function and test it separately, rather than testing the entire program. For shorter programs, I like the approach I'm using in this video. In this next version, I've added the GameOver function. This shows what you would do in a bottom-up implementation. Since the GameOver function does not call any other functions, once it is done, we can test it completely. Since games are played to 15 and you only need to win by 1, the game is over when either player has 15. You might want to use greater than or equal to 15 instead of just equal to 15, but since we will be checking if the game is over at the end of every rally, there is no possibility the score will be greater than 15. In a true bottom-up implementation approach, we should now test this function. We can open the console and use from rball3 import star to bring in all the functions and call GameOver with a couple different values. To test it well, we should call it with a couple scores in which the game is not over, and one in which each player wins to make certain the OR condition is the one we want. We can see that it worked correctly for each case. Next, we'll add the code to the Sim1 game so it returns valid values. In this case, player A always wins. Now we can write the simEndgames function and call the Sim1 game function. We need an accumulator pattern to add up the wins for each player. We use a loop to simulate the appropriate number of games. Since the Sim1 game returns the scores at the end of the game, we just check which one is larger to determine the winner and update the appropriate accumulator variable. When the loop ends, we return the number of games each player won. We can run it, and as we expect, player A wins all the games since our Sim1 game function currently returns that player A wins. Now we'll work on the Sim1 game. We need to import the random function from the random module so we can randomly determine who wins a rally. We'll use the accumulator pattern to keep track of the score of each player. We also need a variable to keep track of who is serving. We'll start by letting player A serve first. We don't know how many rallies it will take for the game to be over, so we need to use a while loop. There's a slight chance we could get an infinite loop if each player kept alternating winning rallies, but the chances of that happening are very slim. Since we have the GameOver function, we can use that as a condition. Note how this makes it very clear when the loop runs. It executes while the game is not over. Now we have two options depending on which player is serving. If player A is serving, we check if a random number is less than their probability of winning the rally when they serve. If so, we update their score, otherwise it is player B's turn to serve. We have the mirror image case if player B is serving. After the rally ends, we check again to see if the game is over, and if not, repeat the process. When the loop ends, the game is over, so we return the score of each player as the simEndgames function expects. We can run it and see that it appears to work, although player B wins most of the games. In the hard-coded values of the getInputs function, we indicated player B was better than player A. If you think about it, this isn't too surprising, since if you're not serving, you need to win 2 rallies in a row to score a point. So if one player is slightly better than the other, they are much less likely to score a point. We'll now complete the program by adding the printIntro and getInputs functions. Even though these were the easiest functions to write, I left them for last because they weren't needed to work on the rest of the program, and it saved me from needing to enter values each time we ran it. We'll also make the sim1game function more fair by giving each player a 50% chance of getting to serve first. We can now run it with a couple different values and see that it works as we would expect. As we discussed for the previous version, the slightly better person wins most of the games. Of course, the steps I used to write the programs aren't the only ways to do it. Some programmers might not bother with a game over function, and some might not use separate functions to print the intro or summary. Some might not write a separate function to simulate one game, and instead put it all in the sim_endgames function. But hopefully you see that the more you split it up, the easier each problem is to solve. And of course, the order you write the functions could vary, but the key thing to do is to write a little bit and test it. If you write the entire program and it doesn't work, then it's more difficult to determine which specific part isn't working correctly. If you write a bit and that doesn't work, you know that part is incorrect.